Assalamu alaikum. Welcome to another session of data structures and algorithms using C and C++. My name is Dr. Bilal Wajid, and today we're going to continue from the place where we last left. We were trying to add elements in a sorted manner. We've already discussed cases 1 and 2, and now we're going to discuss cases 3 and 4. Now, as a precursor, we've been discussing double linked lists since lecture 28. This is lecture number 34. In the last lecture, we talked about add, where the double linked list, while adding elements, is sorted. It retains its sortedness during the add process. So you have to make an add function that ensures that your double linked list is sorted by default. Now, we have two global variables. One is the length that helps us retain the current length and capture the current length of the double linked list. So whenever you add, you increment it by 1. Whenever you delete, you decrease it by 1. All lists, whether they are single linked list or double linked list or circular linked list, have a start, a pointer that points at the beginning of the double linked list. At the very beginning, that start points to null. And then you have a structure, the quintessential element about double linked list, that it has a pointer that points to the next node and a pointer that points to the previous node. Now, we discussed the case what happens when the list is empty. Well, if the list is empty, you shouldn't be running an add function. You should rather be redirecting the user to a create function. Now, case 2 was, what if you're trying to add a value, let's say 5, which is smaller than everything that's in the double linked list? Well, if it is the smallest value, then that node becomes the first node. And we see that our double linked list actually grows in size, and 5 becomes the first node and then starts point to 5 and not 10 as was done in the previous slide. Now, the other case is, what if you're trying to add some value, let's say 15, a new node which falls in between two other nodes? Well, that is our case 3, and let's discuss it. You begin by, having a pointer by the name of current, which points to start. And then when it points to start, you really need to find what is the most appropriate position so that we can plug this in. This new node which contains the value 15. So you can run a while loop which tests if the node next to the current node is a null. This is not null, so that condition is valid. And then if this value is smaller than this value, we see that both conditions are satisfied. If both conditions are satisfied, now we ensure both by using this double and sign. You can update current to point to the next node. So current is updated to current's next. Okay. Now you can go back and recheck. So you can check this value. If it is indeed smaller than this value, we see that in fact is the case. And then you can also check if current's next is not null. We see it is a node, it's not null, so both conditions are met. And then we can update current to point to the next node, and we see that happening. Now, we should check again, let's run the while loop again, and this time we see, well, the current's value, the value that current points to, is not smaller, it's actually larger. So this condition is violated, so then the while loop ends. You don't update current anymore. But the interesting thing here in this example is, well, current's next node is also not equal to null. It is in fact null. So both conditions are violated, in which case current is not updated anymore and it stays here. So now if it stays here, we need to check which of the functions should we work. Is it the last node that we are trying to add, or is it the middle node? Well, if current's value is larger than the value that we are trying to put in, then it actually should come here and not here. Otherwise, if it's smaller, then the value should be coming here, as we will see in case number 4. So in other words, we are going to call out the add middle node function, and we are going to pass the same value 15 over here. Now the add middle node is its return type is deliberately kept void because we already are keeping length and start as global variables which are accessible from everywhere. So void add middle node, you have this integer x which is the same as 15 in our case, and then you're passing the current location of this pointer current. Okay, so now you have both the start and length, which is courtesy of they being global, and then you have the value 15 which you're passing and the current location of the current node. Okay, so now we need not one but two pointers. One is A and one is previous. Now A is assigned a location in the memory which is new node, and then that value that A points to is updated to the value x, which in our case right now is 15. Then notice here that this is 10, this is 15, and this is 20. So this node should actually squeeze in between these two nodes. And we can do that by, changing the pointer this to here and this to here. Let's see how that's done. So the first thing is that previous should be pointing to current's previous, so that's this guy. And this guy right now, 10, shouldn't be pointing to 20, it should actually be pointing to 15. Notice I've actually colored it blue deliberately. So previous is next shouldn't be pointing to current, it should actually be pointing to A. And we see that that's exactly what has happened here. And then obviously because it's a double linked list, A's previous should also be pointing to this guy, which the location is being held by previous. So A's previous is updated to this guy. Now obviously because 15 is to be present in between 10 and 20, so 15's next, so A's next should be assigned current, and current's previous, which right now is pointing to here, shouldn't be pointing here, but rather it should be pointing to A. And we see that's been done. So now if you look closely, the double linked list starts from 5, then travels to 10, and then 15, and then 20, and then ends. So let's redraw this to make it look nicer. So 15 actually looks in between 10 and 20. Okay, so that's drawn and shown here. And because we see that now that the length of our double linked list has actually increased by 1, we always ensure to increment the length by 1. Okay, so that was our case 3. Let's look at our last case. What if you're trying to add a value which is larger than all of the values? So in other words, let's try to add 50. Now I'm going to rerun this code again so that you have an idea and you are fully grasped in this current situation. So you need a node current which is assigned to start, and then you're going to check, this value, is it less than 50, and is the next node not equal to null? If it isn't, if both conditions are met, you're going to update current. You're again going to check the same, this value, if it's indeed is less than 50, and if this is not null. We see that both conditions are met, so you update current. And you repeat the process again up until you actually reach the end. Okay, so now when you try it one more time, you see, well, current's value is less than x. That's true. So 20 is less than 50. But current's next is not equal to null. So one condition is true and the other condition becomes false, because both conditions need to be true because of this AND sign. Therefore the current is no more updated and it stays here. So if current is no more updated, we really need to check what's going on here. Well, current's value is not greater than x, right? 20 is not greater than 50, so we're not trying to put anything here. Therefore the only place which is left to put some new node is at the very end. Okay, so add last node, and we can pass it the value 50 because that's what the value of x is. So let's see how this works. Okay, so the add last node is a function of the type void for the reasons I've discussed several times before. You need a new pointer by the name of A, and you're going to assign it a location in the memory equal to the size of the node, and you can do this by stating A has been assigned as new node. Now the value that this new node is going to contain is going to be the same as the value 50, in which the value that A is pointing to has been assigned X. Now because this is the last node, this node shouldn't be pointing to null anymore. It actually should be pointing to here. Because we know the location of this last node because of the current pointer, we can say current next is now pointing to A. And that's how you write this down. Obviously, because this is a double linked list, we have to return the favor. So A's previous now needs to be pointing to current. Right now it's not pointing to anything. So A's previous points to null. We've done that. And A's next now needs to point to null. Right? So now we can redraw the same thing in a slightly different way. We can put this 50 here, and that's what it looks like. Right? Obviously your double linked list has increased by 1 length, and we should always remember to increment the length by 1. Okay, so that covers our add function and all the 4 cases associated with it. Remember, the add function that we've made in this program for a double linked list is in fact and ensures that double linked list is sorted by default. Right? In the next lecture, we're going to run all the codes of a double linked list, and we're going to see a running example how it actually works like. Again, remember to try these codes before proceeding ahead. Subscribe and hit the bell icon to get notified for newer videos. Thank you very much. Up until next time, bye bye.